Hello and welcome to Pre-Calculus Trig, Section 1.2 on right triangle trigonometry. So in this unit, we're going to have a standard way of putting our letters on our triangles. So our capital letters A, B, and C will be used for the angles. And our lowercase letters A, B, and C will be used for our sides. Okay, so side A is opposite angle A. Side B is opposite angle B. And side C is opposite angle C. So in our unit here, C will always be your 90-degree angle. All right, so the Pythagorean theorem holds for right triangles, and this says your hypotenuse squared, your long side that's opposite your right angle, is equal to the sum of your legs squared, a squared plus b squared. Or it could say b squared plus a squared, it wouldn't matter because sums are commutative. So we use Pythagorean theorem to find a missing side if we know two sides. So taking this first problem, this first triangle, we have a number here on the side, and this one here we don't know. So we can call, using our opposite lettering system, this would be C and this would be B. Here A is unknown. So we can say C squared is equal to A squared plus B squared. We know C is 5. So A is our unknown, and we know B is 4. So that's 25 is equal to A squared plus 16. And then we subtract 16 from both sides, so that's 9 is equal to A squared. Then we take the square root of both sides, so that's A is equal to 3. Right, so we found our missing side. Looking at the second example, our missing side is our E here. All right, so doing our opposite side lettering, little d would be this side, little f would be this side, and little e is labeled. So we'll say f squared, the hypotenuse squared, is equal to d squared plus e squared, or it doesn't matter, e squared plus d squared. So f is 2, d is 1, e is unknown. So we have 4 is equal to 1 plus e squared. 3 is equal to e squared. Taking the square root of both sides, I'll have e is equal to the square root of 3. So on this triangle here, we've got the missing side being the hypotenuse this time. So this side is y, this side is x. So setting up our Pythagorean theorem, we're going to say z squared, my hypotenuse squared, is x squared plus y squared. So z squared is equal to 1 squared plus 1 squared. So z squared is equal to 1 plus 1, which is 2. Taking the square root of both sides, I'll get z is equal to the square root of 2. So we use the Pythagorean theorem to find a missing side when we know two of the other sides. So we can do an application problem involving the Pythagorean theorem. So this is your classic ladder problem. A 20-foot ladder is leaning against the house. So here's the wall of the house. The base of the ladder is 8 feet from the wall of the house, so that's your horizontal distance. What is the perpendicular distance from the ground to the top of the ladder? So h is perpendicular to 8, so this is your right angle right here. So we have a right triangle formed by the ladder leaning against the wall. So if I call this side x and this side y, this side is labeled as h, I can set up my Pythagorean theorem with y being my hypotenuse and x and h being my two legs. So I'll say x squared plus h squared should equal y squared. All right, so x we have 8, h is unknown, y we have 20. All right, so we have 64 plus h squared is equal to 400. H squared is equal to 400 minus 64, 336. So the square root of h squared, the square root of 336, h is equal to, so let me just plug that into the calculator, 18.33. So that would be feet. So it's up the side of the wall, 18.33 feet from the ground. So on these ladder problems, sometimes it'll ask you for the length of the ladder given these other two sides, or sometimes it'll ask for the height that it is from the ground, the perpendicular distance here. So it can ask for either of those three sides given the other two for now. We'll learn other variations of this problem once we get into angles. So next we're going to talk about the 6 trigonometric functions, and what they are side ratios. So the length of one side divided by the length of the other side is what I mean by a side ratio. So we have this little triangle on the side here. If I'm talking about an angle theta, this is your opposite side. And you can determine that by drawing an arrow and hitting the side like that. That's your opposite side. The hypotenuse is always going to be the side opposite your right angle. So that leaves your adjacent side as this side over here. So if you can identify your opposite side, then you can pretty easily figure out the other two. Right? So then we have what we call the 6 trigonometric functions here, and their side ratios. So as you can see from this table here, the sine of the angle theta is the ratio of the opposite side divided by the hypotenuse, and the cosine is the ratio of the adjacent side divided by the hypotenuse, and the tangent is the ratio of the opposite side divided by the adjacent side. So that takes care of this side of the table. This side over here, these functions are the reciprocals of these functions. So if you can get these, then you just turn them upside down and you have the other side here. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. So we have a way of easily remembering the left-hand side, SOHCAHTOA. You may have heard of this when you're in geometry. So it takes the first letter. So if I'm talking about the sine, this S stands for sine, this O stands for opposite, and H for hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you can use this to develop these, and once you have these, you flip them over to develop these. The only other thing that requires not messing up as far as a memory thing goes, this is the way I memorize it, sine does not go with secant. All right? It would make more sense, I guess, in your mind maybe to have S go with S, C go with C, but it doesn't. So sine goes with cosecant because they don't match, and cosine goes with secant because they don't match. That's how I remember it. The first letter doesn't match on the reciprocal functions. This one's easy to remember because the tangent and the cotangent sound a lot alike. Sometimes people get these mixed up though because they want the first letter to match and it doesn't. All right, so we're going to be using these so much that you'll probably get that memorized pretty quickly. So let's do an example. So given the following triangle, find the 6 trigonometric functions of the angles alpha and theta. So let's do alpha first. So I'm standing on alpha. There's alpha. That means this is my opposite side. This is my hypotenuse always. And this is my adjacent side. So I'm going to find the sine of alpha, the cosine of alpha, the tangent of alpha. And then I'm going to flip those upside down, which would give me the cosecant of alpha, the secant of alpha, and the cotangent of alpha. So I'm going to use SOHCAHTOA to help me with that. Right? So let's do sine first. So sine is opposite over hypotenuse. That would be 12 over 13. Cosine is adjacent over hypotenuse. So that would be 5 over 13. And then tangent is equal to opposite over adjacent. So that's 12 over 5. Now to get the other side filled in, I take the reciprocals. So I'm going to just flip them upside down. And I'm done. Now I'm going to do the angle alpha. I'm going to do the same thing, so I have to relabel, and this is critical. You've got to stand on the angle you're talking about. So if I'm doing theta now, that means this is opposite, this is hypotenuse, this is adjacent. So let me write my table. So I wrote my table. Now let's fill it in. So sine is opposite over hypotenuse. So that would be 5 over 13. Cosine is adjacent over hypotenuse, 12 over 13. Tangent is opposite over adjacent, 5 over 12. And then I've got my reciprocals on the other side, cosecant, secant, and cotangent. So what you have to be very careful about is the labeling of the triangle. If you're talking about the trig functions of the angle alpha, you're going to label it according to your perspective. You're going to stand on the alpha to label opposite, adjacent, and hypotenuse. If you're looking for the 6 trig functions of theta, you're going to be standing on the angle theta to label your triangle. So that's what we got to be careful about. All right, now let's do an example. So this says solve the triangle, which means find all of the sides and all of the angles, and we're going to round to the 10th place. So given this triangle here, let's first label it. So that means we've got C opposite C, A opposite A, and B opposite B. So we're looking for all 6 parts, 3 angles, and 3 sides. So I'm going to make a chart. So here's my chart. So I know angle B because it's given to me as 40 degrees. So I can write 40 degrees here. I know angle C because that's my right angle, 90 degrees. And I'm given side B. Side B is 12. So I'm left finding the other 3 pieces. So we have 3 known, and we'll have 3 that we got to find. All right, so I'm going to use SOHCAHTOA to help me out with this. So I'm going to write this down. SOHCAHTOA. But the first thing that I'm going to remember from back in geometry and even back in middle school that the sum of the three angles of a triangle is equal to 180. So that means angle A plus angle B plus angle C must equal 180. All right, so that's very important. All right, so we know two of them already. The only one we don't know is 80. So we've got 40 plus 90 is equal to 180. So that's A plus 130 is equal to 180. So subtracting 130 will have 50 degrees. Right, so now we know all three angles. Now we go over to the triangle and we label the sides standing on 40. So I would go opposite. So this is your opposite side. Of course, this would be your hypotenuse, which means this is your adjacent side relative to the angle 40. So I'm going to use my trig functions to find the two missing sides. So if I use the opposite side, I have a number on here, 12, then I could either use this side A or this side C as my unknown. All right, I really want to use this 12 though, otherwise I'll have two unknowns in my side ratios and I won't be able to solve that. All right, so let's say I used 12 and C in my equation. I'd be using opposite and hypotenuse. Opposite and hypotenuse means I need the sine function. So I could say sine of the angle 40 is equal to 12 over C. Then I could put a 1 under my sine 40 and I could say C sine of 40, C times the sine of 40, using a cross product, is equal to 12 times 1, which is 12. Solving for C, I would divide by the sine of 40 on both sides. All right, so C is equal to 12 divided by the sine 40. All right, here's where we need to go into the calculator. So since we're working in degrees, you're going to make sure your calculator is set to mode degrees. So you can either use a regular handheld calculator or any of the calculators you can find on the internet that have sine, cosine, tangent on them. All right, so making sure it's set in mode degrees, you can find the sine button on the calculator. So I'm going to punch in 12 divided by the sine of 40. So I got 18.669. I'm going to round that to the tenths place, so that would be 18.7. All right, so I've only got one more side to find. So my last side that I need to find is A. Well, since I know two sides, I could use Pythagorean theorem if I wanted to, but I'm going to go ahead and set up another trig function just to give you some practice. So as soon as you get to the point where you know two sides, you can always use Pythagorean theorem. But what I want to caution you about is if you choose to use Pythagorean theorem, that you use the unrounded number in your calculation, and then once you get to your final result, then you round to the tenths place. All right, so you don't want to have accumulated rounding error in your problem. All right, so now we're going to set up an equation for finding side A. And when you're doing these, you want to really try to avoid using your decimal numbers in your calculations when you can. So I'm going to look at 40 here, and I'm going to say if I want A in my equation, that means I need to put an adjacent side in it. All right, so the other number is on my opposite side, so I need opposite and adjacent. All right, so I go up here. That means I'm going to use tangent. Tangent is opposite over adjacent. So you figure that out by using the number you're given and the side you're trying to find. So I'm going to say tan 40 is equal to opposite, which is 12, over adjacent, which is a. All right, so I can solve this. So I'm going to say a tan 40 cross multiplying is equal to 12 times 1. Solving for a, I would divide by tan 40, and that would be 12 divided by tan 40 in your calculator. So scientific calculators are going to have a tangent button. Make sure in your mode degrees 12 divided by the tangent of 40. So I get 14.301. All right, now I'm going to round to the 10th place. So that would be 14.3. All right, so now I've got my table finished, so I've solved my triangle. So on these kind of solving the triangle problems, you're going to be given 3 pieces of information. One of them will be this right angle, which is 90 degrees, so that's 1, 2, 3. And you'll have to find the other 2 pieces of information. It could be a different set of 3, but you'll be given 3 and you find 3. So that means you've got this equation to find one of the angles, this equation to find one of the sides, and this equation to find the other side. This third step here could have been done using the Pythagorean theorem, but I chose to use a trig equation for the last calculation as well. So that's the end of this video. We're going to do a few more examples in part 2 of the lecture for section 1.2.